Hello everyone, in this tutorial I'll tell you how to draw shear force and bending moment diagram for a simply supported beam subjected to a point load. This is the example of simply supported beam of a span 5 meter and it is subjected to a point load of 10 kN at its midpoint. So first label the diagram. This is point A, this is point B, and C is the midpoint of the beam, and this is reaction RA and this is reaction RB. So to draw shear force and bending moment diagram for a simply supported beam, first we have to calculate RA and RB. So how to calculate RA and RB? We have to apply equilibrium conditions. So equilibrium conditions are, first one is sum of all horizontal forces are 0. Then second one is sum of all vertical forces are 0. And last one is sum of all the movements about any point are 0. So the first equilibrium condition is sum of all horizontal forces are 0. In this diagram there is no horizontal force, so this will not apply. Now before applying a second and third equilibrium condition, we have to consider the nature of forces and the nature of movements. So I am here considering the upward forces as a positive and downward forces as negative. And then clockwise movements as a positive and anti-clockwise movement as negative. Now in this diagram, upward force is RA and second upward force is RB and downward force is 10 kN. So sum of all these vertical forces should be 0. So RA plus RB becomes equal to 10. This is equation number 1. Now apply the next equilibrium condition, that is the sum of all the movements about any point are 0. So by taking the movements about point A. So consider A as a center, and due to 10 kilonewton, 10 kilonewton is at a distance of 2.5 meter. It tends to rotate the beam in clockwise direction, so it is positive. RB is at a distance of 5 meter. It tends to rotate the beam in anti-clockwise direction, so it is negative. So sum of these movements should be 0. So from this equation we can calculate the value of RB and it comes out as 5 kilonewton. When we put this value RB in equation number 1, then RA also comes out as 5 kilonewton. So the value of RB and RA both comes out as 5 kilonewton. Now after calculating RA and RB, we can draw the shear force and bending moment diagram. So there are two methods to draw shear force and bending moment diagram. First one is left and right hand method and second one is section method. So in this tutorial I'll tell you to draw shear force and bending moment diagram with the help of left and right hand method. So first one is shear force diagram. So to draw shear force diagram, we have to take each point 2 times and do the summation of all leftward forces. So first point in this diagram is point A. So shear force on just left of point A. So there is no force on just left of point A, so it is 0. So shear force on just right of point A. So place your hand on just right of point A and do the summation of all leftward forces. So on the left side it is 5 kilonewton. 5 kilonewton is the force which is acting vertically upward, so it is positive. Next point is point C. So shear force on just left of point C. So place your hand on just left of point C and do the summation of all leftward forces. So there is again one force, that is Ra, which is acting vertically upward, so it is positive. So now shear force on just right of point C. Now we have to place our hand on just right of point C and do the summation of all leftward forces. So first leftward forces Ra, that is 5 kilonewton upward positive and 10 kilonewton is downward. So net effect is minus 5 kilonewton. Now the next is point B. So again shear force on a just left of point B. There are two forces, 5 and minus 10, so net effect is minus 5 kilonewton. Now shear force on just right of point B. So place your hand just right and do the summation of all leftward forces. So first one is 5 kilonewton is upward, 10 is downward, then 5 is upward, so net effect becomes 0. Now we got two values on each points. So A is having a 0 and 5, C is having 5 minus 5 minus 5 and a 0 last point. So we have to plot all these values on a reference line. So extend these lines take a reference line, extend the point C also. Now plot all the points on this reference line. Upward is positive and downward is negative. So first point is A. A is having 0 and plus 5. C is having plus 5 and minus 5. Take approximately, and then minus 5 and a 0. Now join all these points with a straight line. So this is our shear force diagram. Now to draw bending moment diagram, take again one reference line. Now we have to calculate bending moment on each point. Bending moment diagram. So first point is point A. Bending moment about point A. So on the left side of point A there is no force, so bending moment is 0. Now bending moment about point C. On the left side of point C there is one force, 5 kilonewton. It is at a distance of 2.5 meter and it tend to rotate the beam in clockwise direction. So it is plus 12.5 kilonewton meter. Now the last point is point B. So point B, on the left side of point B there is a RA. RA is 5 kilonewton at a distance of 5 meter. It tend to rotate the beam in clockwise direction, and 10 kilonewton is at a distance of 2.5 meter. It tends to rotate the beam in anti-clockwise direction, so the net effect becomes 0. Now we have to plot all these values on this reference line. So A has got a 0 value, C is 12.5 kilonewton meter and B is a 0. Now I join all these points with a straight line. So this is the bending moment diagram. Now thanks for watching the tutorial. Stay home and save lives. Thank you very much.